Okay, so looking at worksheet 1, what do we want to talk about? 2, okay. So I'm going to try to do this like the simplest way possible and not over-explain. I think part of the issue has been my desire maybe to over-explain some of these things, and that's getting old, so I would try to be a little bit more sparse. If I do something and you don't understand, let me know and I'll give more explanation, but I'm going to try to do this a little bit more concisely than maybe I have been, as I think that's maybe some of the information is getting overloaded and that's causing some of our problems. Is that okay? Okay, so I just wanted to put that out there beforehand. So first thing I'm going to do is determine, I'm going to look at the cosine theta that we have available to us here. So cosine is positive in what quadrants? 1 and 4, because cosine is x, and the x coordinate is positive in quadrants 1 and 4. The interval from pi to 2 pi covers what 2 quadrants? 3 and 4. So the quadrant where my answer is going to be in is in quadrant 4. No, I swear I changed that color. So that's my angle that I'm looking for. Everybody okay with that? Okay. What I'm going to do now is I need to rewrite this angle in terms of something that I can find. That's going to be this piece. So I'm going to use a different variable letter, or that's a different Greek letter. And the relationship is that theta is equal to 2 pi minus phi. Any questions on how I came up with that part? Okay. Since 2 pi, or I'm sorry, since theta, let me start over. Since phi is an angle removed from a orientation on the xy axis, notice I drew the arrows at both ends. I'm not talking about a standard position like an angle of rotation. I'm just talking about a regular old angle like in a right triangle angle. Because of that, to find, I can just look at that value of cosine as if it was in the first quadrant. That's why the absolute values are going to be there. Because that angle phi in the first quadrant is going to be the same as the size of that angle there, right? Since it'll always be a positive number, that's all I care about. is I always want that acute angle. So now I can just go to my calculator and do 2 pi minus cosine inverse of root 2 over 2. Or, since this is a question asking us to use the unit circle, I can go to the unit circle and locate the place where cosine is positive root 2 over 2 in the first quadrant. Megan Tompkins. Because we're looking for the size of this angle. My Zoom call, of course I did. Don't mind me, it's just everything going wrong all at once kind of day. That's you every day. That's got to be frustrating. Life's hard. Yes. Mm-hmm. Okay. So, yes.
You know how they lined up so that it was 12 number on the third quadrant?
Yes.
Does that happen every time?
Yes. You're welcome. Okay. Should we do? Okay. Hold on, everybody. Let's refocus here. Yes, Jessica.
Wait, okay, so for this one, I just looked at so I do that the percent data equals positive or 2 over 2, so I just went to the domain of
Mr.
pi
Gulick.
to 2pi, and then I figure out where x was positive or 2 over 2 and found my own.
Mr. Kulik,
1 second, Dan. I'll be right with you.
you're muted.
Yes.
Is that okay? Or
Yes.
okay.
So again, I'm giving you this explanation because it's going to be the same explanation for worksheet 1, 2.
Okay.
So like, it's rather than having two different ways of kind of doing it, it's just like, ideally, yes. And the place where your method would get into trouble is if you have something that's going around more than one rotation or going the opposite direction. Is the other place where you can run into a little bit of trouble with what you're describing. But for the majority of these problems, it's fine.
Okay. Are you talking about
I'm talking to Jessica, who asked, like, okay, I saw that this is cosine is positive, and I know that this is in 3 or 4, so I just found the spot in 3 or 4 where it's positive, and I just looked at my unit circle and read that answer off, which is fine for this problem. Will it always be fine? And the answer to that is, well, depending on what that interval that's given is, if that interval is bigger than 2 pi, no, you're going to have to do like find something coterminal to it, or if that angle is, or that interval has got something negative in it, again, you might have to find an angle coterminal what you're finding on the unit circle, but more or less it's going to be fine. I'm giving you this explanation because it doesn't change when we go to worksheet 2. Which I think is the advantage of like having just one way of doing it. But again, not wrong what you described doing, Jessica.
Okay.
And hold on, Grace.
Yeah, I was just wondering, like, do you always use the first quadrant? I mean, if we don't produce that one.
You can,
Okay.
is what I want to say. You can always do it that way. You don't have to always do it that way, but you could. Okay. Shall we do another one of these? Okay, what's next? Anybody with a request here on worksheet 1? Number 4. Does that work okay for you guys? Okay. So, tangent is negative in what quadrants? 2 and 4, right? Since tangent is y over x, it needs to be in quadrants where only one of the coordinates is positive and the other is negative. 0 to pi is what quadrants? 1 and 2. So we know the answer we're looking for is in quadrant 2. So since that interval is between 0 and 2 pi, we could, as Jessica suggested, just go to the unit circle, locate quadrant 2, and find the place where cosine or tangent is negative root 3. So I know tangent is y over x. So I'm looking for the place where the y coordinate has a square root of 3 in it, and the x coordinate is, in this case, negative. So I have positive root 3 over negative 1. Notice that the denominators are both 2. So if I write as a fraction, that like denominators of 2 cancel out. So this is my location, which is 2 pi over 3. Okay? So that's a perfectly reasonable way of doing it. Alternatively, what we had done before, what is it? Why do I have a color? We're drawing our angle in the second quadrant. So there's my angle theta. And we need to find this little spot here, the phi. The relationship between theta and phi is that this is pi minus phi. And since phi is like a triangle angle and not an angle of rotation, I can find that by just looking at the tan inverse of the positive version of tangent. And if I go to my unit circle, I'd find that's pi over 3. Oops. Which is the 2 pi. So again, either way of doing it is fine. The advantage of this way that I just showed you is that it's basically the same version that you do on worksheet 2. Just instead of going to your unit circle, you go to your calculator to find that inverse, but like whatever. Is this feeling a little better? Trying not to over-explain. Let's one more of these maybe, and then we'll move on to something else. Oh no, we have 2. Leah?
Yeah. Oh, 11.
11?
That
So
works.
that works?
Yeah.
Okay. I just was going to try to see if we'd find a compromise between you two, but if you're good, it makes life so much easier. Oh, and this is a good one. Okay, so tangent is positive in what quadrants? 1 and 4. I'm sorry, 3. 1 and 3, right? Either both x and y are positive or both x and y are negative. 3 pi to 4 pi is what quadrants? So if we think about it, 0, pi over 2, pi, 2, 2 pi, 2.5 pi, 3 pi, 3.5 pi, and 4 pi, so it's 3 and 4. Is that okay? I just walked around so like here's 90 degrees, that's half of a pi. Here is 90 degrees, that's another half a pi. Just to figure out the quadrants for what quadrants 3 pi to 4 pi is doing. So this is like 1 pi is those 2 quadrants. There's 1 pi to 2 pi, those 2 quadrants. 2 pi to 3 pi, 3 pi to 4 pi. Is that okay? You're welcome. I'm going to erase that messy picture now because I need a little bit of space, but okay. Now I pressed black. Why is it giving me red? I just don't understand this machine some days. I'm trying to go too fast, apparently, for it. Okay. So the angle that we're looking for is actually this one, right? Everybody agree with that? Notice it going around more than once. So here, to find this theta, we're going to relate it again to this size angle here. We'll call phi. Or we could go to the unit circle and find something coterminal. That would be okay also. So in this case, normally this would be pi, right? This piece right here. But because we've gone around more than once, this is actually pi for us. Everybody okay with that? Because my answer has to be between 3 pi and 4 pi. Right? So I have to keep going. So I know my answer's in the third quadrant. So here's pi, 2 pi, 3 pi, and then a little more. So it has to be more than one surround. Does that feel okay? Okay. Yes, Ben? Of course. You're welcome. So here we're going to be going 3 pi plus that angle phi. And how do we find phi? Well, it's just going to be the value of tangent in the first quadrant. So what's helpful here, instead of thinking about this as square root 3 over 3, I'll think about it as 1 over the square root of 3. So the y-coordinate should have a 1 in it, and the x-coordinate should have a root 3 in it. If I go to my unit circle and I look at that, I'd have pi over 6. Is that okay? Or if we're looking in quadrant 3, we would have picked 7 pi over 6. Everybody okay with that? If you're doing Jessica's method? I don't mean to keep referring to it as Jessica's method there, Jessica. I'm not trying to pick on you or nothing. I'm just, you suggest and it works, so I'm going to give you credit where credit is due. And doing it the way that we've written out here, this would be 3 pi plus pi over 6. Or if you're doing Jessica's, we'd have had, I forget what it was now. It was 7 pi over 6, and we'd have to add 2 pi to it. Either way we go, we're going to end up with 19 pi over 6. Oh my goodness, I don't know. Help me. Caroline! You've asked enough questions where I should be remembering this. I feel bad. So our angle theta is in the third quadrant, but this angle phi is always going to be a first quadrant angle. Do you understand why that's always going to be the case? It'll always be positive, that's true. Do you want to, that's kind of it. Since this is always like a distance, there's always like an acute angle from a right triangle, that's why it's always a first quadrant angle. Is that okay? Okay. You're welcome. Leah.
Just mentioned a really basic question about how do you know that tangent is in quadrant 1 and quadrant 2?
So remember that tangent is y over x.
Yeah.
That's going to be a positive number when you have positive over positive, like quadrant 1, or if you have negative over negative, like Is that okay?
Yeah.
Megan?
Can you just explain how you got like the square of 3 over 3 and 1 over 3?
Yeah. Actually, I don't need it. So if I have square root 3 over 3, well, I know 3 is the same thing as like the square root of 3 squared, right?
Yeah.
So I can just reduce, and it's the same thing as 1 over the square root of 3.
Oh.
Like if I had x over x squared, it'd just be 1 over x, right? So that's how I did that simplification. And the only reason I did that is because I know that if I was looking at my unit circle, this is coordinates would have looked like, where I know that there's no 3 in the unit circle anywhere as a coordinate by itself.
No, it makes sense why I did it. I just don't like it.
Oh, okay. Feel better about it though? Oh, okay. Yeah, Dan?
So why do you add 2 pi after you get 7 pi over 6?
The answer needs to be in the between 3 pi and 4 pi. That answer is not. That's only between 1 pi and 2 pi. So I'm just going to find an angle that's coterminal to it by adding 2 pi.
Okay, thank you.
You're welcome. So the 7 pi over 6 ensured it was in the correct quadrant, but then I had to check that it also lay inside of that interval that we're asked to find our answer at. Since it didn't, and it was too small, I just knew to add 2 pi to it, and that would take care of it. Bella.
Oh, okay, so how did you get 7 pi over 6?
The unit circle.
Right, but like, I get confused with tangent on like what points to like look.
So I looked for the place where I had the y coordinate had a 1 in it,
Okay,
and the x coordinate had the square root of 3 in it.
okay.
And that was when it was 1/2, square root 3 over 2 comma 1/2. Actually, they were both negative, but that's what I did.
Oh yeah, that makes sense.
Okay. All right. Are we ready to move on to the next sheet with our questions? Is that okay? I don't want to cut anybody short, but we've done several here. I don't want to not end up having time to talk about the other ones because it sounded like we had questions from everything. Am I going okay at speed-wise? Not going too fast? Okay. 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 What do we want to look at from worksheet 2? Six. Sure. Okay. So first thing I'm going to do is I'm going to think about this as tan theta equals negative 5.95. So I'm going to go, okay, what 2 quadrants is tangent negative in? That's quadrant 2 and quadrant 4. I think we've done that. We mentioned that already, right? Now 4 pi to 5 pi, well, this is 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then 4 to 5 is back up here again. So that's quadrant 1 and 2. Is everybody okay with that? Delaney? That's where tangent is negative. So tangent is y over x. So I just need one, either x or y, to be negative, but not both. That happens at the second and fourth quadrants. Okay. So now I'm going to draw my picture. So my answer should be here in the second quadrant. So to get to that, that's 1 pi, 2 pi, 3 pi, 4 pi, and there's my answer. So I had to go around twice here. So theta is going to be just short of 5 pi. And I'm going to find that phi by doing tan inverse of the absolute value of negative 5.95. So I'll go to my calculator. 5 pi minus tangent inverse 5.95. And that gives me 14.30. If you wanted to make sure you did it correctly, you can always go back in and type tangent of, well, let's just do the answer. Do that. And that should give me negative 5.95, which it did. Sophia?
Could you do that like the other way? Or is this the only way?
So you can't do this the other way because we aren't able to use the unit circle, because negative 5.95 isn't a value, like a ratio from our unit circle.
Okay.
So you have to kind of think about it this way and use the calculator,
Okay.
which is my motivation for wanting to go do it the other way on worksheet 1, so it's still the same way this one.
Uh-huh.
Just we're retrieving that value of phi with a calculator instead of the unit circle. Leah?
Is there another problem like that?
Yes. Do you have a preference? Okay. Delaney, do you have a preference? You had your hand up. No. Sure. Let's do 5. That's fine. Does that work for you, Leah?
Yeah. I was just going to say, so for the first part, does that mean that it's in quadrant 1 or quadrant 2?
Yes.
Okay.
So cosine theta is positive in quadrant 1 or quadrant 4, right? Because cosine is the x-coordinate. The x-coordinate is positive on the right-hand side. Is that okay? Is that what you said before, Delaney, or did I misunderstood you? I said it, and then I was like, oh, was that not what she said? I guess I was a bad listener. Okay, so there's that. Now we have to figure out what 2 quadrants 11 pi to 12 pi is covering. Well, let's just draw a picture. So 0 to 1, 1 to 2, 2 to 3, 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 11 to 12 is 1 and 2. Is everybody okay with that? Okay. So our answer we're looking for is in quadrant 1. So that's 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. I counted that wrong somehow, right? That should be 3 and 4. How come nobody yelled at me? So there's my angle. Jeepers creepers, how many times would we have to go around there? It was 5 and change, right? So this is going to be 12 pi minus that phi. And that's just going to be 12 pi minus cosine inverse of 0.92 or 0.19. So 36.2-ish. Or 19 or something. I don't remember what it told you to round to. And if you wanted to check this, 1232. I wasn't even close. I think I was looking at the wrong 2 decimal places. You can just do cosine of that answer, and you should get 0.19. Ashley. So when we say reference triangles, like that's really what I did there. Well, the directions ask you to do it that way, although you could do it by graphing still. Like, that's not an incorrect method, it's just not following the direction. Is that okay there?
Yeah.
Okay. Leah, you had your hand up also.
I'd say nothing.
Oh, okay. Well, that was convenient. Should we do another one for this, or we feel okay? Is it starting to feel any easier? What?
That's right.
Okay, that's good.
Number 12.
Of course.
Oh, wait, sorry, 11.
11 is fine also. Okay, so we'll start by figuring out where cosine is positive, which I think was the same situation as before. That's in quadrants 1 and 4. 3 pi to 4 pi is quadrants 3 and 4. I think we've done that one already. Everybody's okay to there? So our answer is going to be in quadrant 4. So we have 2 pi, and then a little bit after 3 pi, there's our answer. So we're going to do 4 pi minus phi, or that's our phi. And in our case, phi is just going to be cosine inverse of, since 0.87 is already positive, there's no need to take an absolute value of it. So just go to my calculator. 4 pi minus cosine inverse 0.87. So 12.05. And if you wanted to check, cosine of 12.05 is 0.87. Does that feel okay, Bella?
Mm-hmm.
Okay. Leah?
So, for example, with like number 10, is pi over 2 kind of equivalent to like 7 pi over 2 and then 3 pi over 2? Like how pi is like the same, or like 2 pi is the same as 4 pi.
Hi. I don't have one.
That might be a problem. Can you come see me after school?
Sure.
You can, we'll figure it out, and we'll figure it out together.
I didn't realize we needed one since it wasn't a.
This is the front.
No, that's the back. This is 4th hour, not 5th hour.
Yeah, I know.
Oh, okay.
So there's one more empty. Is that?
No, there's 4 rows. There's these 3 desks that Ben is the
You
only
guys are-
person that
you're
ever,
special.
Ben is the only person that ever sits in that desk because this is the only class I have more than 24 students in.
I got you.
And we didn't have more than 24 at the start of the year.
But nobody's there.
Correct.
Okay.
Those are
here.
empties.
We can talk about this.
Okay. Hi. Okay. Leah, you were asking about,
So like 7 pi over 2, that would be like up at the top, right? It's like in the same spot that pi over 2 would be. 3 pi over 2. But
yeah, hold on, I just want to, no. So here's pi over 2, and then 1 pi more would be 3 pi over 2. And then this would be then 1 pi more, so this would be 5 pi over 2. And then 1 pi more would make this one 7 pi over 2. Yep. Although I think the negatives, they'd be the reverse direction since this is negative pi over 2 down here. So if you're looking at this one, I think it's the opposite ends. But I don't do that just in my head. Like I draw the picture and figure it out.
Yeah.
You know what I mean? Like I get what you're asking me, but I can't, like I literally, there's too many rotations for me to like look at it without the picture.
That's kind of what I wanted.
Was good enough though?
Yeah.
Okay. Yeah, you're welcome. Jesse.
I'm glad you did the work.
Yeah. Yeah. After this, well, can we move on to 4?
Yeah.
That's fine. Okay. Do that over here while I still have the black pen. Okay. So this tells me tan theta is positive in quadrants 1 or 3. Negative 4 pi to negative 3 pi. Well, this is 0 to negative 1. Negative 1 to negative 2, negative 2 to negative 3, negative 3 to negative 4. So we want our answer to be in quadrant 1. So 0 to negative 1 pi, negative 2 pi, negative 3 pi. There's our answer. So our answer is going to be, here's where it's going to get a little tricky since we're doing negatives here. So I'm going to do negative 2 pi plus the positive result, which is the opposite of what we'd have been doing if these were positive values.
Why do you use negative 2 pi?
Oh, I'm sorry, 4 pi. Great question. I wasn't supposed to. So that's 1107. I'm sorry, negative 1107. So if we do, just to check, tangent of that negative 1107, we should get 1295, which is what we get there. Is that okay, Jesse? So you're kind of trailing off there, and between that and the mask, I couldn't really it's okay. It's okay. I do the same thing. I'll start mumbling something that's to myself, and I'm not even totally sure if it's to me or to the other person. I'll just start talking because it helps me think. It's no big deal. Okay. On to 4. Any of these tickle your fancy? Sounds good. Okay. So I'm going to just look at the inside part. So remember that arctan is the same thing as tan inverse. And so theta equals tan inverse is the equivalent, theta equals tan inverse is the equivalent of tan theta is equal to x. And I remember that tangent is really like opposite over adjacent. So if I draw a right triangle with this as theta, the opposite side would be x, and the adjacent side would be 1. Okay with that? By the Pythagorean theorem, then, I'm going to have 1 plus x squared as the hypotenuse. Right? A squared plus b squared equals c squared. Okay? And now cosecant is the hypotenuse over opposite. So there we go. So I'm going to use the inside part to build my right triangle, and then I'll evaluate the outside part using that right triangle.
Lost.
1 plus x squared? Yeah. Are we done writing? Can I scroll down to 7? I don't want to cut anybody off. We're good? Okay. Down to 7 we go. Okay. So again, that arc cosecant is the same as cosecant inverse. And that's the same thing as saying cosecant theta is equal to 2x plus 1. And I remember that cosecant theta is hypotenuse over opposite. So there, that's my theta. Oh, sorry. Hypotenuse over opposite. So to find that adjacent side, I need to do the Pythagorean theorem. I'll just call it y for now. So 2x plus 1 squared, I have to do 2x plus 1 times 2x plus 1. So when I FOIL that out, I get 4x squared plus 4x plus 1. And when I subtract 1 from both sides, I get this. And we'll square root both sides. So that's going to give me 2 root x squared plus x is equal to y. And cotangent theta is adjacent over opposite. So that's going to be 2 square root x squared plus x over 1. Does that feel okay? We're good with what I did going from there to there? factored out the square root of 4 from each, which is just 2. Sometimes I do those simplifying steps and I sit down and I look at it later. I'm like, ooh, did they catch what I did there? They probably did, but I should probably just come back and double check. Sophia. Uh-huh. Are everybody done with 7 before I move? Can 4 be the last one? And I'll just give you the rest of the time in class to work on getting caught up on these. Okay. Okay. All right, so cotangent inverse of x. This is equivalent to cotangent theta is equal to x. And cotangent is adjacent over opposite. So there's my right triangle. The adjacent side is x. The opposite side is 1. So using the Pythagorean theorem, I get that. Everybody okay there? Okay. So secant theta is hypotenuse over adjacent. So that's square root x squared plus 1 over x. Ooh. Delaney?
Number 7 is the reason we did the coiling. Is that correct?
Well, the Pythagorean theorem wasn't so simple because instead of solving for the hypotenuse, we had to solve for one of the legs. But we foiled because we had a quantity squared. That's what squared means, is you have 2x plus 1 squared means 2x plus 1 times 2x plus 1. Is that what you're asking? Okay. All right. Yeah, of course. Reminder again that all this stuff is in the content library. So if you need to go back and look at anything we did today, it's all going to be there in the notes for dated today. And we recorded the whole thing, so if you want to go back and watch how we did any of these parts, the video will be up in the under the chapter 4 stuff on the class page. Probably not till later today or tomorrow, but it'll be up there here soon. Sophia? Those are my favorite kind of questions. Right? Like, how good does that feel when you figure it out? I love it.